Today I want to talk about differentiation, but in a special way. So we're going to try to differentiate a fairly complex function, and I'm going to define it as such: yx equals fx to the power of gx. And we want to differentiate this. So the first step we're going to do is we take the logarithm on the left and the right side. So we get log yx equals log fx to the power of gx. Now, according to the logarithmic rules, you can say that this is the same as gx log fx. Right? And now we're going to differentiate the left and the right side. The left side I'm going to differentiate towards y, and the right side I'm going to differentiate towards x. So we will get log y differentiated equals 1 over y, and I'm leaving the x out for now, times dy. And then the right hand side is going to be the differentiation of this function. First I'm going to use the product rule, so I'm going to differentiate the first component, gx, and write out the second one. And then I'm going to write out the first one and differentiate the second one, which is 1 over fx times the derivative of f towards x times dx. This all goes with dx. Right? Now we're going to collect dy dx on one side, so dy dx, and we're going to multiply left and right by y, and y is fx to the power gx times gx log fx plus gx over fx times fx and x, the derivative of x with respect to x, the derivative of f with respect to x. And there you have it. Yeah, the derivative of this complex function equals this identity. Let's check it with one very simple example. Let's say y is x squared. We know that the derivative y, which is dy dx, we know that that equals 2x. Looking at fx to the power of jx, we can identify fx with x and gx with 2. Yeah. So we're going to fill this out, and we get yxn equals dy dx equals fx, which is x, to the power of 2 to the power of jx. The derivative of gx, which is the derivative of 2, which is 0, so that goes away. Gx, 2, divided by fx, which is x in this case, with the derivative of x, which is 1. Yeah? And that gives you 2x. And that's indeed correct. Right? I feel this is a good place to stop. If you like this video, please like and subscribe. And I'll see you next time.